let's look at example 8. This is the start of section 8.4, points of intersection. So here we've got parametric equations, x equals at squared plus t, and y equals a in brackets t cubed plus 8. T is defined for any values, real values of any real values. Okay, you've got a point -4, 0 is where the graph intersects the x-axis. Using this information, we'll be able to find the value of a. So we're going to solve a pair of equations where you're going to substitute x is equal to -4 into the first equation. So at squared plus t is going to be equal to -4. And y is equal to 0 needs to satisfy this equation. So a t cubed plus 8 is equal to 0. So a times something is equal to 0. Since a is non-zero constant, divide everything by a. That will happen for t cubed equal to -8. That gives me t is equal to -2, cube root of -8. So using this information, we can substitute -2, because that happens at that point over here, into the equation that we got from using the first parametric equation. And we are going to get a multiplied by -2 squared plus -2 is equal to -4. So that gives me 4a -2 is equal to -4, so 4a is equal to -2, so a is equal to -1/2. So the two equations that we are working with now are x is equal to -1/2 t squared plus t, y equals to -1/2 t cubed plus 8. So now we can find the point of intersection with the y-axis by substituting x equals 0 into this equation. So x is equal to 0, we are going to get -1/2 t squared plus t equals to 0. So we're going to factorize t, and you'll get two possible answers. So this happens for t equal to 0, or t -1/2 of t plus 1 equal to 0. So that gives me 1/2 of t equals to 1, t is equal to 2. Now these two values allow me to find the y-coordinates of this point A and the point below, point B. So let's find y's, because we obviously know that the x-coordinate is 0. So the y function is -1/2 t cubed plus 8. So let's substitute t equals 0. So that gives me y is equal to -1/2, 0 plus 8, so -4. And this one, t is equal to 2. So y will give me -1/2, and that will be 2 cubed plus 8. So 8 plus 8, which is 16, divided by 2 is 8, but it's a minus, so -8. So you can see that point B has the y-coordinate -8, point A has the y-coordinate -4. So point A is 0, -4, point B 0, -8. In example 9, we've got y equals t squared and y equals, sorry, that must be x, copied it wrong, x equals t squared and y equals 4t. Now we need to find the points where the curve, which is defined by parametric equations, meets the line x plus y plus 4 equals 0. So the way you do it, if you've got the equation of Cartesian equation of the line and parametric definitions of the curve, you can just substitute these into the line and find the value of t when it happens. So that means they will find the value of t when the line and the curve intersect. So x is equal to t squared, y is equal to 4t, and then you've got 4. So this is t plus 2 and t plus 2. So you could see that there is only one point of intersection because you only get one value of t. T is equal to minus 2. Substitute this minus 2 into the parametric definition. So you get minus 2 squared, that's 4. And then you get y is equal to 4 multiplied by minus 2, which is minus 8, giving us the point 4 minus 8. So that is the point A. Example 10, parametric equations. One is x equals cos t plus sine t. The other one is y equals t minus pi over 6 all squared. T varies between minus half of pi and up to 4 pi over 3. Find the point of intersection with the line y equals pi squared. So that line here is a horizontal line. The line, you're going to replace it with y with pi squared. This is just a number, so if you do pi squared, you get 9.869. So this is like saying find the intersection with that line, so which is just a horizontal line. So we're going to substitute y, pi squared instead of y, and then solve that equation. You need to be very careful when you do this because let's just imagine this is you are trying to solve it, getting exact answers. So if you've got something squared is equal to 4, then that something squared is going to give you plus and minus square root of 4. So this is a very similar thing. So you've got t minus pi over 6 could be equal to plus or minus pi, giving us t is equal to pi over 6 plus pi as the one possible value of t when it happens, and t is equal to pi over 6 minus pi. This gives me minus 5 pi over 6. Because minus 5 pi over 6 is outside the range, we can reject this. So we're not interested in that solution. So we're only going to consider when t is equal to 7 pi over 6. So when t is equal to 7 pi over 6, the x-coordinate is cos 7 pi over 6 and plus sine 7 pi over 6. So this gives us, check with the calculator, minus root 3 over 2, and that sign is negative half. It's minus root 3 plus 1 over 2 if you take the minus outside the fraction. I'll leave it like that. The y-coordinate, we need to put 7 pi over 6 into this equation. So you will have 7 pi over 6 minus 1 pi over 6. So you got 6 pi over 6. So it's pi squared. So minus root 3 plus 1 over 2. And then pi squared is the answer. Okay, so for part B, we've been asked to find where the curve crosses the y-axis. So the y-axis is going to be when x is equal to 0. So we are going to solve cos t plus sine t equals to 0. So this is a typical multiple of cos equals to multiple of sine, or multiple of cos plus or minus multiple of sine equals to 0 will lead to a tan question. So let me just quickly rearrange it just so you see. Let's put that minus here. Divide everything by cos. you will have minus cos t over cos t. That will give me minus 1, and then sine t over cos t. That gives me tan. So we've got tan t is equal to minus 1. So tan t is equal to minus 1 when t is equal to minus pi over 4. And then if you add pi, you'll have 3 pi over 4. So because our t's are between minus pi over 2 up to 4 pi over 3, we need to consider both of these values of t. So x, we're talking about the y-axis, so the y-coordinate is going to be when t is equal to minus pi over 4, sub it into the equation. So that gives me, if you change it into 12s, that's going to be 3 and 2, 5, minus 5 pi over 12 squared, which is 25 pi over 144. And when t is equal to 3 pi over 4, y coordinate is going to be 3 pi over 4 minus pi over 6 squared. Again, let's change this into 12, so that's going to be 9 minus 2, 7 pi over 12 all squared, giving us 49 pi over 144. So this one is going to be the lower point, and this one is going to be the higher point. So I can't remember what they were called, A and B or P and Q. So this one is the higher. Just noticed a mistake over here. Of course, we've got pi squared because pi will get squared. So the answers will be 0.25 pi squared over 144 and 0.49 pi squared over 144 as our solutions. So now you can move on to exercise 80.